It may be one of the most important detection systems ever created. Radar, for all its sophistication, has a fundamental limitation. It cannot penetrate water. Once an object disappears beneath the ocean surface, it effectively vanishes from traditional tracking methods. That reality posed a serious problem during the Cold War, when submarines became some of the most dangerous weapons ever devised. Silent, mobile, and capable of launching nuclear missiles from virtually anywhere, they represented an invisible threat. To counter that threat, scientists and military engineers turned to sound. Underwater, sound behaves very differently than it does in air. In fact, at certain depths, typically between 600 and 1,200 feet, conditions of temperature, pressure, and salinity combine to form what is known as the deep sound channel. Within this layer, low-frequency sound waves can travel astonishing distances, sometimes thousands of miles, with minimal loss of energy. It is as if the ocean itself contains a natural acoustic highway. Recognizing this, the U.S. Navy built a vast, classified listening network known as the Sound Surveillance System, or SOSUS. This system consisted of hydrophones, highly sensitive underwater microphones, strategically placed along the ocean floor at precise depths. These devices were connected by undersea cables to onshore listening stations, where trained analysts monitored incoming signals. The network spanned enormous areas of the Atlantic and Pacific Oceans, effectively turning the seas into a monitored acoustic environment. Initially, SOSUS worked exactly as intended. Submarines, no matter how quiet, produce noise. Engines hum, propellers churn, and hulls vibrate as they move through water. These low-frequency signatures could be detected across vast distances using the deep sound channel. Operators could track submarines thousands of miles away, providing a crucial advantage in the geopolitical tension between superpowers. But something unexpected happened. Operators began detecting sounds that did not match any known vessel or mechanical system. These signals were powerful, low-frequency, and strangely organic. They did not resemble engines, propellers, or any known human-made technology. At first, technicians suspected equipment malfunctions. The signals were so strong and so unusual that they seemed almost impossible. Investigations were launched. Analysts compared the recordings against every known naval profile. They examined the possibility of secret enemy technology. Nothing matched. The sounds did not behave like machines. They did not accelerate or decelerate in predictable ways. They seemed to come from vast areas simultaneously. The answer, when it finally emerged, transformed marine science. The mysterious sounds were produced by whales, specifically large species like blue whales and fin whales. These animals generate extremely low-frequency vocalizations, often below the range of human hearing. Within the deep sound channel, their calls can travel across entire ocean basins. What had initially been mistaken for unknown machinery turned out to be a form of long-distance communication among the largest creatures on Earth. This discovery revealed something profound. Whales were not just making noise. They were communicating across immense distances. Their calls could span thousands of miles, enabling coordination of migration, navigation, and possibly even social interaction on a scale humans had never imagined. For centuries, these sounds had existed unnoticed. They passed through ships, through the water beneath coastal cities, and through the lives of countless sailors without detection. An entire acoustic world had been hidden in plain sight. The implications extended beyond science. The military quickly realized that the presence of whales could actually help submarines remain undetected. A submarine positioned near a singing whale could effectively blend into the animal's acoustic signature, making it far more difficult for enemy sonar to distinguish it. In a strange twist, whales became a kind of natural camouflage. As time went on, SOSUS proved useful in other ways. It recorded catastrophic events with remarkable precision. In 1963, when the USS Thresher was lost during deep-sea testing, the system captured the acoustic signature of its implosion. Analysts used these recordings to pinpoint the location of the wreck, demonstrating the system's extraordinary sensitivity. A few years later, in 1968, the USS Scorpion disappeared under mysterious circumstances. Again, SOSUS data helped locate the wreckage. Yet while the system could reveal where and when such events occurred, it could not always explain why. Some details remain classified, leaving lingering questions about what truly happened in those final moments. As technology advanced, analysts also began identifying consistent acoustic patterns from enemy submarines. For example, certain Soviet submarines produce a faint but distinctive frequency due to mechanical resonance. Once recognized, this signature allowed for continuous tracking across great distances. It was a significant strategic advantage. However, not all detections could be explained so easily. There were reports, serious, formal reports, from trained personnel describing underwater objects behaving in ways no known submarine could. These objects moved at extraordinary speeds, far beyond the limits of conventional engineering. They descended to depths that would crush any known vessel. They appeared and disappeared without the gradual acoustic signatures associated with engines. Such reports came from multiple sources, across different locations, and from experienced operators. They were documented, classified, and largely left unexplained. As portions of SOSA's data were eventually declassified, scientists gained access to decades of underwater recordings. Among these was a particularly puzzling signal detected near the deepest part of the ocean. This sound, later nicknamed the biotwang, combined characteristics of biological calls with something almost mechanical or structured. For years, its origin remained unknown. Eventually, advanced analysis suggested it was likely produced by a species of whale, demonstrating once again how much remains undiscovered in the ocean. Even familiar animals can produce entirely unknown behaviors under the right conditions. Yet not every mystery has been resolved. Modern detection systems have expanded beyond sound. Advances in physics and computing have introduced new methods of tracking objects underwater. One such method involves detecting magnetic anomalies. Submarines, being large metallic structures, slightly distort Earth's magnetic field as they move. This creates a faint but measurable signature. For decades, this signal was too weak to be useful. The ocean is full of magnetic noise from natural and environmental sources. Distinguishing a submarine signature from this background was considered nearly impossible. Artificial intelligence changed that. Modern algorithms can process enormous volumes of data and identify subtle patterns that human analysts would miss. These systems can isolate the magnetic signature of a submarine in real time, even amid significant noise. Sensors capable of detecting these anomalies can now be deployed on satellites and drones, dramatically expanding their reach. This development has major implications. The long-standing assumption that submarines are nearly undetectable is no longer entirely valid. If submarines can be reliably tracked, it could alter the balance of global military strategy, particularly regarding nuclear deterrence. And once again, the technology is revealing unexpected things. In recent years, researchers using advanced detection methods have identified unusual structures on the ocean floor. In one case, scans revealed geometric formations buried beneath layers of ice and sediment in a remote region. These shapes appeared organized and structured, unlike typical geological formations. The materials detected did not match the surrounding environment. The formations showed patterns, straight lines, right angles, that suggested intentional design rather than natural processes. Some researchers speculate they could be remnants of ancient activity, possibly dating back thousands of years to a time when the region's climate was very different. Such interpretations remain controversial, and no definitive conclusions have been reached. But the discovery highlights how little we truly know about the depths of our planet. The ocean floor is vast, largely unexplored, and filled with secrets. Each new technological advancement reveals more new species, unknown sounds, and unexpected structures. Some findings fit neatly into existing scientific understanding. Others challenge it. And then there are the reports that remain classified. Military and research organizations around the world have documented detections that do not correspond to known technology or natural phenomena. These include objects transitioning between air and water at high speeds, descending to extreme depths, and producing no detectable acoustic or magnetic signatures. The individuals reporting these observations are trained professionals using calibrated instruments. Their accounts are taken seriously, recorded, and stored, often without public explanation. The sensors built to listen for submarines have done far more than that. They revealed an entire hidden dimension of the natural world, exposed the limits of human knowledge, and hinted at mysteries that remain unresolved. The ocean, covering more than 70% of Earth's surface, is still one of the least understood environments on the planet. Every new tool we develop to study it uncovers something unexpected. We built these systems to detect threats. Instead, they showed us how much we have yet to discover.